Hello and welcome back to Statistics1, section 8.2, confidence intervals for one population mean when population standard deviation sigma is known. That's title. So we are getting one step closer to being able to predict mean off of using the sample with certain confidence. Last time we talked about the error, margin of error, and we talked about the test statistic. We said, not testing, point estimate. And we said that we can use, the idea is to use the sample mean to approximate the population mean. And then we have margin of error, which would be the tolerance, which you add and subtract depending on how confident you are that the mean is between numbers. So today we do calculations for that. And one of the important aspects of today is, I'll write it here in blood, sigma is known. And that's never the case, okay? So you don't know, if you don't know population, you're definitely not going to know standard deviation. But if you don't know the mean, you don't know the standard deviation. But that's okay. So this is just sigma is known. And next lecture will be sigma is unknown, which is when we are going to use those new charts I've been mentioning, the t-scores. All right, so what do we have in our calculation here? Well, we are going to construct the confidence interval using the confidence level, which would be a percent of how confident you are in your research and data and all of that. So number one, so step one, well, let me put to get the confidence interval called CI at confidence level alpha, we do this. All right, number one. So find the confidence level of 1 minus alpha, use table to find the z-score. So for confidence level 1 minus alpha, use use the z-score chart or table to compute, or to find, not to compute because it's already given, just to find z alpha over 2. And I'll explain why it's over 2. And then second part is the confidence interval is given by, and it's going to be a range of numbers, x bar minus z alpha over 2 times the sigma divided by square root of n for a given sample size, and x bar plus z alpha over 2 sigma over square root of over n. Now, this part over here is that margin of error, which we call D. Same as that. Now, before we do any of the problems, no new calculations here. You have the formula, just plug stuff in. And you know how to use the z-score chart. So no new calculations, no new concept, sorry. All we do is we worry about what it means and proper way to compute. So before I mentioned that a mechanic gives you an estimate from $50 to $150, and you can ask how confident your mechanic is that the price will not exceed $150, and pretty much due to experience, depending on experience, they will tell you pretty sure or not as sure or completely just guessing. That's, you know, something that you have to take into consideration. Now, you want to pay a particular price, and then we have the idea of what the whole service is going to cost. Now, before we do into calculations, we have to take a look at this. Let's write it as a question. What it means to be, no coughing, 95% confident. So what it means to be 95% confident. All right. What you are having here is a number that can be converted into the z-score eventually throughout the. But before we do that, guys, if I draw one of those bell-shaped curves, 95% confident is here, leaving you with two tail ends to deal with. So if you have two tail ends to deal with, and the middle value is 0.95 in area, because, right, such is life, then you have to have 0.025 and 0.025 left over as areas, because the entire area has to add to 1. So both of these together will be 0.05, and then 0.05 added to 0.95 is 1. So this is what your z alpha over 2 is. Why alpha over 2? Well, notation is there just to help us remember that you actually have two of these areas, one to the left and one to the right of these numbers. So now 1z would be used for positive calculations, and the other negative z, right? So this would be a negative z alpha over 2 here. And you can see them in your formula. Here's your negative z, and here's your positive z. So this alpha over 2 notation is just something that we use as a notation to denote that there are two regions, one to the left and one to the right, and your mean is supposed to be trapped somewhere in between these values. And you will have 95% confidence that that mean or that price or whatever is going to be in there. So now, how do I compute this z-score? Well, you can compute the z-score by simply looking at the z-score chart, and you are looking for the z-score of 0.025. So what do we get? I'll write it this way. Area equals 0.025 produces the Z alpha 2. So what is the, who has the chart? It's online, okay, fine. The chart is online. Everyone log on to online. That was very particular. I can't see anything on these charts. Should have brought my chart from the office. There it is.
Oh, sorry. So 0.5080.
We will know soon enough if this thing ever opens. There we go. Control plus. Z-score chart. You see that the only left-hand side is shaded, which means that you have your also left-hand side shaded over there, and you need 0.025. What happened? Wait, what was my area?
It's only 2 decimal points, so it should be 0.02.
Yeah, 0.02, so it's over here. 0.02. 268? No. This one?
Oh, no, go to your right.
What was my area? 0.025.
0.025.
So,
the exact one.
oh, 256?
Oh, go one more.
No. Left.
There we go.
250.
That's what I said. Pay attention. So negative 1.96. Oh, this is the one value you're going to memorize. So Z-score is negative 1.96. So this means that you have, and I can also put, you immediately have a positive one as well. Because on the chart, from the other side, you would have all of the area, and then you have to subtract from one and do all of that stuff, but it's symmetric. So you just need to find the one on the left, and the one on the right has the same numbers except its opposite sign. So this is what it means to be confident 95%, because you actually, you get the Z-scores that we will be using later. Yes?
I'm just asking about mu. Like, what should we call that?
I can't hear you.
Like, on the tail ends of the curve chart,
Okay.
how we have positive and negative z,
Yeah, this one.
mu. Yeah.
There's no mu, just Z alpha over 2.
What do we call it? Alpha.
Oh, you mean this symbol?
Like, it's not on the board.
It- Oh. There we go. This symbol is alpha.
The entire thing, the z, right after the area, after the arrow. So
This is just a Z-score.
that's okay.
Yeah, it's just a Z-score, and we use this notation here because it's a half of, we need to remember that one half goes one side, the other half goes the other side.
So that's mu divided by 2.
Alpha divided by 2.
Or alpha.
Alpha is the just a Greek letter A. Greek version of letter A. Alpha. You are. So now, CI is given as x bar minus z alpha over 2 sigma divided by square root of n, and then x bar plus z alpha over 2 sigma over root n. So this is our CI. You have this formula already here. So now we can go and we can solve problems. So what do we have? Let's say we're going to jump into homework. Oh, nightmare, took forever to get there. Alright, so what do we have? We have the margin of error, we have, let's first find perfect. So what should we look at? Political prisoners or Rolling Stones or medical marijuana, American alligators? Alligators. 878. So multi-sensor data loggers were attached to free-ranging American alligators in a study conducted by someone. Behavior on American alligators monitored by multi-sensor data loggers. That will be Aquatic Biology, Volume 18, page 1 through 8, if you want to take a look. The mean duration for a sample of 68, so sample of 68, that's lowercase n, sample of 68. And they say the mean for that sample is uh, 338 seconds. So x bar is 338 seconds. .338, yes. So assume that the standard deviation is 100. So this is what they say, assume, because we're doing this in stages. The next lecture will throw that through the window as well. And so these are the three pieces of information that we have. Find 95% confidence interval for the mean duration mu of an American alligator dive. Okay, great. So they're looking for CI. That's what they're looking for a confidence interval. And they're looking at 95%. So we get to reuse the numbers from our previous calculation or problem, whatever. So where do we begin? Well, we first find z alpha over 2, and we did that before, so we know it's plus minus 1.96. Right? We found that here by using the log tables. I mean the z-score chart. Now, I have the formula, which is this one, x bar with the z-score and so on. So x bar is 338. Don't forget the parentheses, right? Minus 1.96 times the sigma, which is 100, divided by the square root of n, which is 68. And then we have for the upper limit, so upper limit would be plus 196, good effort, divided by 68. There we go.
So the first is volume.
So all I need to do is to copy. Yes?
First is volume.
Yeah, because it's interval, right? If I say class is between 1 and 3, then the lower number is 1, upper number is 3, so you have a lower limit than the upper, right, for the interval. Lower number and a higher number. So when you use negative z-score, that's one on the left, you're getting the lower limit and then the one in the plus. Yes? So now we punch this in a calculator and we get some decimals. So let's do the calculator thing. Depending on which calculator you have, you can possibly all do this in one shot. 338 minus 1.96. Well, I could have just, yeah, that's times 100, divided by the square root of 68. Calculator says 314.23. And the upper one, I just use second entry and change minus to a plus. 361.77. If you want the full credit, make sure you label this sentence so you can study it. Answer. So everything up to this point is partial credit. Here is the for the full credit. You say, I am 95% confident that mu lies between 314.23 and 361.77. So this is what we have as an answer. What does this mean? Well, just your regular interval, right? You have a number inside the interval. That number is now your mu. Now, what is your mu? Well, the best point estimate that you have right now is going to be x bar, because x bar is the mean of the sample, mu is the mean of population, so mean is mean. Well, it's not really mean because, it's not really the same, because the mean of population is the exact value and the mean of the sample is the one that approximates it. So what we are doing is we are creating this range of numbers, and that's the same what mechanic gives you when you go for an estimate or contractor or whatever. So they give you the range of values and say the mean is going to be somewhere in here, and I'm 95% or 98% sure, or if you want really to be terrible, you will be 10% sure. Right? So it's a game between how confident you are in the range of numbers, right, which we call the interval, and that will depend. So when you change your confidence interval, what changes is the z-score, which is z alpha over 2. So you can have at 95%, I'm going to pick a different problem now. Or actually, wait, is there more? They also want us to construct 99%. Great, so we're going to now repeat the entire problem, but at 99%. Because the previous one was done at 95%. Okay, so now here part B. No need to be dramatic for that. There we go. We'll say that the confidence level now is 99. So confidence level is 99%. Okay. So for 99%, we draw our, there we go. And now I need 0.99 in here. That means that this is 0.05, 0.005 as areas. And those will spawn a negative z alpha over 2 and positive z alpha over 2. So we're just going to look at the negative, and we are looking, so now, to get z alpha over 2, look at z-score chart. We have area 0.005, and that's going to give you your z alpha over 2. Now this one is going to be the negative one, and then for the other one you just take away the negative. So when we drop here, we're looking for 0.05. Do we have 0.05? There's a 48.
What happens if it's a 0.051 versus 0.049?
Perfect. All right. I'm not sure if you guys can see my... So right where the mouse is, and I'm going to...
Just with the
Think. Because I could have walked all the way there to figure out, so...
I was thinking about letting you walk there.
Really?
I did.
Like, how random?
You're betraying me now. All these years.
These two numbers are equally spaced from 0.005, which means that both z-scores are good, and we're just going to average those two z-scores. Now, you average the two numbers that are adjacent by just using the lower number and adding 5 after that. So, what do we have there? We have negative 2, 5, 7, and then 5. Negative 2, 5, 7, and we'll add a 5 because we have to average it. So we are averaging because the two areas that are given to us are evenly spaced. Now, if this was a Calculus 2 course, you get to compute this using integrals, right? But since it's not, you just look at the chart, and this is the best we can do without the proper calculations that are meant for this. So now, thank you. So now, I have my z-score. It's still the good old x bar from it's the same alligator problem. It's just we have new z-scores. So confidence interval is going to be 338 minus 2.575 times, no, 68 was, this was 100, divided by square root of 68, comma, 338 plus 2.575, 100 over square root of 68. So this is our confidence interval, and again, you punch all of this into a calculator. I already have all of this stuff, so now it's negative 2, I said minus 2.57. Why? Clear everything. 338 minus 257.5 when you multiply by 100 divided by the square root of 68. Much better. So now the confidence interval is 306.77, and we do second entry here, and just change a minus into a plus. 369.23. Answer. This is, I know it's a part B of the problem, but still you have to answer. I am 99% confident that the population mean mu lies between 306.77 and 369.23. So now when you are observing both of these together, which one is wider? Which interval is wider? Why? Because more confidence means wider interval. Less confidence means narrow interval. Because, all right, so let's say I am oblivious to how much it costs to fix a car, and you are asking me for, a quote, right? How confident am I? I'm not a mechanic. I don't know the pricing, so I'm just going to give you any numbers. Right? So, you have to consider the source. You have to consider the source, and this is where the experts are going to be 95% confident, 99% confident. Now, the more confident you are, the wider the range of where the answer actually is. Now, what do we know about social media? Everyone is very confident over there, right? So what does it mean about the information that you can obtain from it? It's 100% garbage, right? So there is this battle between the two. So if you're looking at this one, right? Let me write both of these numbers on the board. So we have 314. I'm just going to use the whole numbers. So 314 to 361. And that was at 95% confidence. And now you are more confident at 99%. And this is 30, let's round it to 307. And 369. So if you translate this into money, I am 95% confident that your car repair will be between $314 and $361. I am 99% confident. You see, now it's wider. The range is wider. More confidence, I'm just going to add a little bit more to the range to make sure, right, that the answer fits. Now, what are these confidence intervals for? Well, we are looking for we don't know the population mean. All I have is the sample mean. So I'm creating a confidence interval around the sample mean to make a prediction, right, to estimate the population mean. Because, as I said before, you are not going to go and measure all Americans in any aspect of whether you want the average height or average weight or average shoe size. That's not happening, right? But what we can do is we can take a large sample of Americans, let's say 1,000, 100,000, right? Measure their statistic, whatever you want, and then provide the interval around that number and say the actual mean for all Americans is somewhere between these two numbers, and this is how certain I am that mean is there. So is mean 310, right? What is this good? This is good for weight, average weight, right? So 310, right? There we go. But it could be 350 as well. And then in 1% of the cases, I will be wrong. 1% of the case, the average weight might be 306, and that's not in that interval. So the confidence level will provide us with that interval. So what are we doing? We are using the mean of sample, which is the X bar, and we are using the other information to put this together. Let's see another word problem. For this, all right, fuel expenditure, venture capital investments, price of new mobile homes, body fat, political prisoners, Rolling Stones again, pulmonary hypertension, something. Smelling out the enemy. Hold on. Juvenile common lizards. So, not as exciting as you hoped for, right? All right. Oh, by the way, did I say that this is the margin of error? Where's my formula? Yes, I did say that's the margin of error. So if they ask for just margin of error, this is the only thing you have to compute. I'm gonna spell that out one more time over here, just because I have infinite amount of this color. Margin of error, margin of error, known as capital E, is equal to Z alpha over 2 times sigma divided by root n. So just that piece of information, which now tells you that your confidence interval can be written as x bar minus e, comma, x bar plus e. Right? That's that. Good. Let's take a look at the word problem. Which one should we take? Want to talk about lizards? Why not, right? So, what are these lizards? So we're doing the lizards problem. 887. And here are the specs for these lizards. We are going to take a look at 90% confidence interval. So that's a question. Then the lizards are, so the mean number of tongue flicks per 20 minutes for all juvenile common lizards is 456. Wow. No, but they don't, hold on. I'm trying to, because the problem is a little bit written in a tricky way, so I'm trying to get all of the information. This problem 72, they said. Smelling out an enemy, good. And they give us data for this. Great. So they give us data to find, at least they gave us standard deviation of 190, and we have that n is 17. And then we have data to find x bar. So I have no clue who was sitting out there waiting for these lizards to smell out their enemy, counting to 425 flicks of a tongue in 20 minutes because that's how they smell. Pretty much the same like snakes, right? So, data. Kill me now. 425, 510, 629, 236, 654, 200, 276, 501, 811, 332, 424, 674, 676, 694, 710, 662, and since it had to be a 17, we have, right, 633. What are you going to do? So this is data on a sample. They did not count for all the lizards that exist in the world because they couldn't even catch them all. So they had a sample of 17 lizards. They observed those 17 lizards for 20 minutes each, counting every flick of a tongue. This is what you do when you're a graduate student, right? Professor's going to do the research and you get stuck with counting the tongue flicks, right? So, what's your X bar? X bar is the sum of all values divided by 17. So now you have to add all of this mess, divide, and that is going to give us X bar, which is the piece of information that we need to do our other stuff. So now,
I got 532.18.
532.18. Okay, so we're just gonna keep 532 because of the, right? Do you get to do a 0.18 of a tongue flip? I guess you can.
What part this comes from? Oh, that one consider a flick. This is,
Exactly. You go catch another lizard. Because that one is outlier. Can anyone confirm this number? Thank you. So we have 532. All right. And they also want to know margin of error in this problem. Great. 90%, that's terrible. 90% is 0.9, which means 0.05 on each of the sides. Because 5 plus 5 is 10 plus 90 is 100, which is great. I need my Z alpha over 2. That's a negative one, that's the positive one. So we're just focusing on the negative one. So area is 0.05. Gives me Z alpha over 2. 0.05. 0.05. Here is another situation when they are evenly spaced, right? 0.5, 0.5, 0.495, they're evenly spaced. So we take the average, that's going to be negative 1.645. You take 1.64 plus 1.65 and divide by 2. Now, the trick when you're dividing two consecutive numbers is to just take the smaller one and put a 5, because that will be the half of the average going in, right? So I just added this 5 at the end, which was the average. So now I can compute E, which is margin of error. That's going to be 1.645. That's the z-score. Remember, you have a positive and negative of these. And then you have 190 divided by the square root of 17. This is going to give us margin of error. 1.645 times 190 divided by square root of 17. Margin of error of 118.1. Well, we can just call it 118. We don't have to go into decimals. So what's my confidence interval? Confidence interval is x bar minus e, comma, x bar plus e. That will be the confidence interval. Not equal, but the, there we go. So now, we know that the x bar is 532. And then we are subtracting 118 because this is the entire, like this E is that entire formula that you used to have to compute on the side, right? So this is the smaller value, and then 532 plus 118 for the other side. So when you subtract 2 minus 8 is 4, and then 2 minus 1 is 1, and this is 4, so 414. And when you add over here, you get a 10, you get a 5, and you get a 6. There we go. So this is the range at which you are going to have a population mean. So population mean is going to be between these two numbers. Now, you are only 90% certain that the mean is going to be there. So that's why we can use that, we use the z-score chart in areas and all that. Because confidence level, right, which is probability and all that, chops off the regions to the side. Yes. You'll keep getting something else. 1.645. Oh, I have square root of 7. I don't have 17. 75.8. See, good thing you all checked. So I'm going to call this now 76. So margin of error is 76. That was one of the questions. And now these 18s become 76s. And then these numbers here change. So 12 minus 6 is 6. 12 minus 7 is 5. And that's a 4. And then when you add 608. Better? Now, since we only have about 12 minutes, I'm going to teach the use of the t-score chart. We are familiar with the z-score chart. And then the next class we can just come in and do the calculations and then move on to the last chapter, which is Monday. So this is 8.3 prep t-score chart. T-score chart is also available in your textbook. You just flip one page, and then you t-score chart will be used for the samples, right? So what we have is, let's go with, let me just find a t-score real quick. Now, t-score is different, guys. We are going to have something that is called the degree of freedom, right? Degree of freedom. And degree of freedom will be always one number less than your sample size n. So we start with degree of freedom, denoted as df in your chart. And df is equal as n minus 1. So if your sample size is, let's say, 16, then your df is 16 minus 1 equal to 15. So that will be one of the parameters that you have to look at. Another very important aspect of everything here is that your t-scores are areas to the right by definition. I'll write that in blood. So t-score chart, area to the right. So that's the default. The default for z-scores is area to the left. And now, to show one of these charts, they have one tail and two tail, everything on a pile. Oh wait, I can get it in my textbook. So tables, there we go. Perfect. Right on a t-score chart. I have to, oh no, the Control Plus works on this website. So here's what we have. Now, you don't have all of the areas available here because there are way too many parameters to look at. So you only have some available to you. Your degree of freedom is listed on both sides. That's just for your convenience. So these numbers 1 and 1 and 2 and 2, they're the same on both sides. It's just convenient. There are only certain areas that are available for you guys to do this, and these are going to be 0.1, right? So that's 10%, 5%, 2.5%, 1%, and then 0.5%. So, right, this is 80%. This is 90% confidence, and then, right, goes 95%. So only certain areas. You don't have all of them like you had them in the previous z-score chart. So if I want to find, let's see, I want to find the t-score. So find t-score for 0.025 and n equals 19. So the specs are n is 19 and area is 0.025. 0.025. We will have to go to the degree of freedom df 18. So we will look, because of this, we will look for df 18 row, and then look for t 0.025 column. So row 18, 0.025 is 2.101. So t-score would be 2.101. we had to go to the row 18 because our df is n minus 1, so 19 minus 1 is 18. And when you go across, here is where the T0025 is. So this chart is different than the z-score chart. You have to get used to these degrees of freedom. Now, are you going to have degree of freedom for 43? Most likely not, right? Because it goes 30, 35, 40, 50, 60, right? So you do the best you can. You go the closest you can. It's not as easy to get these. So you have all of the values listed up to 30, and then it jumps to 35. So that's the reason why some of your, like 36 is amazing value to have as your sample size, because you use the square root of 36 in calculations, which is 6. And then you also have 36 minus 1 is 35, and you have 35 on this chart, right? You don't have 34, you don't have 36 or 37, but you do have 35, which is 36 minus 1. So 36 is an amazing number, for instance. So that's the way to read these T charts. We are going to review this again next class before we start. But what's happening next class is, finally, which is going to be 8.3, you can get a data. And from that data, for a sample, right, you can come up on your own with the X bar. You can come up on your own with the S, which is your standard deviation for the sample. You will use the T chart to get the T, and you will have exactly the same formula like you had right now, except all of the parameters in the formula are going to be sample based. Instead of Z alpha over 2, you will have a T score. Instead of sigma, you will have S, and then you will have a square root of n. So the formula will look identical, except all of the parameters will be sample parameters, which means that you can finally just look at the sample that you have, and you can make a prediction about the mean. That's next class. We spent, 3.5 months building up to it. So I want to see some hype, right, when you get there. All right, I'll see you all. I will see you all, there we go, on Monday.